moving on, let's look at part B. Zoe is also studying the population of elephants, and E of t also seems to be a sinusoidal function. So here E of t is the number of elephants t hours after 6 a.m. Okay, so maybe this is important, so let's keep that in mind for now. A portion of the graph of E of t is shown below. So here 1 hour after 6 a.m. it looks like you're hitting the maximum. 5 hours after 6 a.m. you're hitting the minimum, and so on. So here's the question. Give the exact values of the next 2 times t when this model predicts there will be the same number of elephants near the lake as there are at time of 2.25, which is 8:15 a.m. because it's after it's 2.25 hours after 6 a.m. You do not need to show work, but they might give you partial credit if you show work. Okay, so t equals to 2.25 is happening somewhere like here. So this is like 2.25, and what they're saying is that obviously this curve, so I can maybe sketch it a little more to the right, this curve keeps on repeating like this, and the question is, when is the next 2 times you're getting this output? So the population of the elephants is the same. So you want to find the t corresponding to this point, and you want to find the t corresponding to this point, because these 2 points are the next 2 times where we get the same output. Now, to begin with, maybe we want to find a period of the graph because we care about hitting the same value again. Now there's one subtlety that we do have to worry about, but I think that is a good first step. So let's think about what the period is. Well, the period is how long it takes for the entire graph to start repeating. And here, for example, we see that this part is repeating over and over again. So if you look at what's happening from 1 to this point to the next maximum, I guess, then we see that that part of the graph is what's actually repeating over and over again. So that's really the period. But what is this distance exactly? Well, we know the distance from here to here precisely. Distance from here to here is 4. So by symmetry, distance from here to here is also going to be 4, going from minimum to maximum. So we know period is 8. So that's a good information. Now, one of the first instinct you might have is that when are we going to get the same output as 2.25? Maybe that's just 8 plus 2.25 at a period, and maybe it's also 16 plus 2.25 at another period. But that's not quite right, because if you think about what sine curve looks like, maybe it looks like this. And let's say I give you maybe a value here. When do you get this value again? Well, you get it actually pretty quickly. This is not the period, because obviously this part of the graph is not repeating over and over again. Sine does not look like this part repeating over and over again. But the point is, even though the entire graph, so maybe this is the period, and the entire graph is repeating every period, it might be true that if I'm only caring about one point, then the same output actually can happen in less than a period. So just adding a period and 2 times period is not quite the right approach, but it is a good starting point. In fact, if I look at this picture, we see from the part from this purple point to the second time it repeats. So this orange part, this is actually repeating over and over again. So we have one copy here, we can put another copy there, and then you can just keep on repeating this orange part. So this part is definitely just one period. So what that's telling you is that the distance from here to the second point, so this distance is actually 8. So you're starting at 2.25, so by adding 8, this point is happening at 10.25. So we found one of them, but we still need to find this one. And you might be like, okay, so it's not quite adding a period. How can we find the x value of this point? Well, there is another symmetry we can exploit. Because the distance from here to 5, which is the minimum, and if you look at the distance from here to also 5, which is the minimum, we see just by the symmetry of the sine curve that these 2 distances must be the same. And now we can argue as follows. We know this point has x coordinate of 2.25. We know this point has coordinate of 5. So the distance from here to here is actually 5 minus 2.25, which is 2.75. So that's this distance. So if I add another 2.75 to 5, then you should be able to get this point just by symmetry. So I'm here considering the symmetry with respect to the minimum here. The sine curve looks symmetric about the reflection across this vertical line, I guess. So that's telling you that this point, the x coordinate of this point, is 5 plus 2.75 or 7.75. In conclusion, we have found that the 2 values are 7.75 7.75 and 10.25.